Hi, today's job is to fit a decoder to this particular model here, which is a Kato, and the Kato clip-in decoder EM13 will be used. Now that controls the motor, and for the end lights they need their own decoder, which is a FL12. Now I have previously fitted a decoder to these other two units, so that went fairly well. Now these two here are both based on the series 127 unit train. And it's interesting to note that only one bogie is powered. Now maybe that's because these particular trains will not have additional cars that can be added other than another 2-car motorised set. Now they have nice blackened wheels but no traction tyre, and really I've found from this one, I haven't run this other one yet, but certainly this one here is atrocious at getting up steep hills. It just slips like nobody's business. So I might try adding a traction tyre from another loco to it to see if that improves things. Now, in comparison, these ones here are based on the series 521 train. And Kato, when they put them out, they have used the old shiny wheels, but they have included a traction tyre. And I've found that these have much better gripping quality than this one. But of course, a train with bogies powered both ends will be far superior, as I've found. Now, after I've fitted a decoder and assigned an address to it, I place a label underneath to tell me what the actual address is and the direction of travel that it's been programmed. And I do the same with any end cars for my trains. I just place a direction label. So these labels just help me to determine which way to set them up on the layout. Also, the 2 in the address indicates to me that it's going to go on yard track number 2. So when I fit the light decoder, the one in the motor car, I have it so that the contact tab, this little strip here, you'll notice each end it's in a different position. This one it's on the side, this one it's in the middle. So I have the middle one facing the front of the car, and that's in the motor one. For the trailer, I have the contact strip that's on the edge facing the end of the car. So in effect they are in reverse for each car, and the white headlights will work in coordination with the direction of travel. Okay, so the motorised car, the underbody, should just move in the direction of the arrow that's on it, and it unlocks it and it will then lift off. And you'll see in here this little plastic tab, this will come out. This has a little push button on the top, a slide button which can turn off the end lights. You then need to remove this wheel set to be able to fit the decoder for the motor. So it's a question just getting underneath, giving a gentle twist, and it should lift out with the drive shaft. The motor decoder should then just slide in. You'll see where it goes. There's this contact strip along the bottom and another one on the top. So this is going to go between and it separates the two. So it just slides in like so. And it's in place. Now if you later find that it's not working, then just come back to this process and just move it around a bit, because sometimes it's not in far enough to make firm contact. Okay, so we now fit the drive shaft back into its slot, and a bit of gentle persuasion and that wheel clips back into place. So I now need to fit this FL12 decoder into this area here to control the lights at the front, and I've orientated so that the contact tab is in the middle and this end it's on the side. So once again it's a question of getting it in here, so it's going to slide in between the contacts which you can't actually see. So these can be a little bit tricky. As I said, if the lights don't work, then come back to this and just jiggle it in position again. Right, so then that should just fit back in, and as we slid it that way to unlock it, you should be able to slide it back to lock it in place. And that's done. So we've got a similar process with the end car. It's a trailer car. It's got a little part tab there to push to release this. Take out this manual cutout switch. And then we position this light decoder. So once again it's a question of sliding it in, and you notice this end I've got around the wrong way, showing white headlights. Now this is my programming track. I only need to put in the loco address, and any other programming I can do on the main line. So I just select program and the quick decoder setup and the short address, which is for this loco is going to be 10. Then I'll write that to the loco. So that's set the program for both chips in there, the motor and the light. I then do the same with the trailer car to set the decoder address for that. It'll be 10 as well. I cannot get any feedback from those light chips, whereas you can from the motor, just by pressing read. I can also program the default settings, which are quite often already pre-programmed, but for that I just need to select number 3 and the CV value of 29 I need to set to 6, and then I'll just write that. And basically that just allows the analog to be in the on position, turns off the speed tables, uses short address, etc. Now for the rest I'll do that on the main track. So I've just started up TrainController. Just the first thing I'll do is go into the railway menu and just set up my digital systems, because I was doing work offline, so I'll change that. It's got a USB connection which equates to COM port 3, so I just select that. Once I've selected it, I shouldn't need to change it again. unless I need to reconnect later, possibly after being offline. As you can see, it's LocalNet COM3. Okay, I'll just put into the running mode. At the moment I'm in edit mode on the screen, just the difference is when it's in running, full running, everything just looks a bit clearer and other notes and things don't appear. But I'll just go back into edit mode. So this is a schematic of the layout. This is the top yard. The stations are represented by this grey strip, and the trains run downhill into the tunnel, out of the tunnel, and come out at this main station. And then from there they can either be doing a shuttle service to and from the subway or circuit, basically whatever I want to do. And I've got various schedules set up to allow for those things. So just go back into running mode just so you can see the trains. This is the one here, and it's actually sitting down on this track, so I'll just put it onto here. The decoder may have provision for, say, 126 speed steps, but my trains are only going to travel slowly, and so it's only going to use a few of those speed steps at the bottom level. But if I find out the maximum speed that my train can run and what step it is, I can change the value of the CV to make that the maximum speed step for the decoder. That means all 126 speed steps will now be within that operating range of the loco, giving far greater control. I also adjust two other CVs, one for the starting speed and one for midpoint speed. So I'll set CV5 to a value of, say, decoder step 70. Write that. I've just gone and modified the maximum decoder value down to 70. Now that doesn't equate to kilometers per hour, it's just 70, step 70 of the decoder. So I'll jump over to this part here, and this has a list of all the trains. So this is the one that I'm going to modify. So to do that I need to do it in the edit mode because I'm going to be changing its settings. And I right click, choose properties for that loco. And this little box tells me what I need to know, that that's the particular symbol for that train. I've got the more various ones loaded there. I've given it a name. I start off with the address value, so it's address 10, it's commuter, and just the series or type of train. Connection is through LocalNet, address 10. Speed is 90 kilometers per hour maximum, and the scale has been entered as 1 to 160. I just find that gives a better response than 1 to 150. Functions where I want to set lights and other things. Resources, mainly for the likes of steam locos where you've got coal or oil and you might want to keep track of how much they're going through. Comments for comments. And back to here. So I go into the automatic speed. Now, at this stage all I want to do is find out how fast it can go with that decoder setting. So this one here is for measurement of 1. I'll slide the decoder value across. So that's going to be maximum speed. And I'm ready to start. Now on this one I've set the decoder to a value of 60 and we'll see what speed that equates. So that's come out at 78. I'll just reposition the loco, ready for the next speed test. For this one I've set the CV5, being the maximum decoder speed step, to 65, and we'll see what that works out at kilometres per hour. Well, that's pretty good. So that was a decoder value of 65, and that equates to 95 kilometers per hour as the top speed. So I'll go with that. So now just set that back to there, initialize the test. This time we're going to do a speed profile. The train will run across the detection track a number of times at different speeds, so that the computer system can gauge what the performance of the engine is. So the length of the detection track is 28 centimeters. The run out, or the run out at each end of that detection track, about 65 centimeters, and it will pause between each run for 2 seconds. So we're ready to start. TrainController internally works with 1000 virtual speed steps for each direction of travel. To do this, it must learn the characteristics of the actual speed steps of the decoder. This requires running the train along this profiling track about 15 times, starting from its slowest threshold speed up to its maximum speed. As you can imagine, it's normally time for coffee while that runs, so I'll speed up the process for you. Okay, there's a bit of a dip in it there, but once it's run in, I'll probably do this again, and hopefully it'll be a nicer speed table. Since filming this video, I found that the loco was still unreliable at climbing the hill. So I changed its maximum speed to 120 kilometers per hour, and now it's not a problem. Also, the way I had it set up, the motor car was actually pushing the trailer up the hill. Now, did you know that if you push a wheelbarrow up a hill, it's much harder than if you were pulling one? It's something to do with the downward pressure you exert on the wheelbarrow, and it's forcing it into the ground and creating extra inertia. So I now run the locomotor first up hills, and that really made a big performance gain. Well, congratulations on seeing the end of this video. You did well to sit through that. It's all a learning experience for me, and it's something that I've actually come to enjoy. The next video, we'll get some trains actually running on their schedules. Catch you then.